Kia ora everyone and welcome back to the IA Max channel. Ahmed Mahi here. In this video, we'll talk about Azure Container Apps. We will be understanding the basics and some of the open source technology built in. So let's dive in. So what is Azure Container Apps? Azure Container Apps is a Microsoft Azure service for containerized apps. We use Azure Container Apps to deploy and manage our apps in a serverless environment. So what we need is simply to package our code in a container, deploy it on Azure Container Apps, and Microsoft will take care of the rest. So no need for us to manage the underlying infrastructure, hence the serverless environment. And the service is a consumption-based pricing only. That is, you pay for what you use and when you use it. So here are some of the Azure Container Apps key concepts. Azure Container Apps is actually built on top of Azure Kubernetes Service, which is awesome because we don't need to have Kubernetes expertise to actually use Azure Container Apps, because Azure Container Apps handles all of this, all of the complexity of Kubernetes for us. But in the same time, we still benefit from the Kubernetes powerful features, things like automatic scaling, load balancing of network traffic, container orchestrations. All of these features are built into Azure Kubernetes Service, and Azure Container Apps is built on top of that. And we get to benefit from those features without having to deal with the complexity of Azure Kubernetes. In a way, we could think of Azure Container Apps as if it is serverless Kubernetes. Next, we'll talk about the concept of environment. So in Azure Container Apps, we use a concept called environment, which is a logical boundary to isolate our container apps. So this is our, as you can see, this is our environment. The idea is that container apps within the same environment actually share the same Azure Virtual Network VNet. And with that, we have like the container apps within the environment would have direct access to each other. And then that simplifies the communication. So we don't have to create complex networking roles. The environment would take care of that. The other thing is that if you want to segregate network traffic between container apps, you need to put them into different environments. If you have, so that you could filter traffic. If you have container apps part of the same microservices architecture and you want them to have direct access to each other, you could put them in the same environment. The other concept here is the concept of revisions. So a revision is, the idea is that a revision is an immutable snapshot of your container app. So by default, when you first create your container app, the first revision is actually created. Any new change to the container, you will be creating new revisions, and a change could be, excuse me, a change could be a container image update or like a container configuration. Those changes would trigger the creation of a new revision. One of the benefits of actually having multiple revision is called traffic splitting. So the idea is that, let's say that you want to deploy a new image of your container and you want to test it before going live. So what you could do is actually you could create what is you could use what is called a traffic splitting. So the idea is that you would keep on sending 80% of your traffic to the older stable version of your container app, and send 20% of the traffic to the new container, just to make sure that everything is working correctly before you fully deploy your new revision and make it migrate it to production. The other concept here is the idea of a replica. So the idea of a replica is that a replica is a new instance of a specific revision. So it's the same revision, but you want to have new instances. So by default, when we create a new container app, we have one replica of our container. As demand increase on a revision, and we need to scale our container app. What happens is that Azure Container Apps would start to scale up, as in scale up horizontally, create more replicas of our revision to deal with the increase in demand. When the demand decreases, Azure Container Apps will start to scale down the number of replicas all the way down to 0 or to the minimum number configured. So when you create a container app, you could actually set the minimum number of replicas to be 1 or 2. So when demand decrease, even if there is no demand, actually, it would always have 1 or 2 containers. Sorry, I should say 1 or 2 replicas running for you. Now let's talk a little bit about some of the built-in technologies that come baked in within Azure Container Apps to provide us with additional features and capabilities. These are things like Dapr, Envoy, and KEDA. So the idea behind KEDA is that it's an open source event-driven runtime. So it provides developers with a set of building blocks to solve some of the common problems of microservices. And also is that it helps simplify the process of building a distributed system, because you don't have to add extra functionality to the application of your code. So Dapr would take care of those extra functionality provided to you through the use of what Dapr calls building blocks. And the beautiful thing about Dapr is that actually it works with different programming languages, different frameworks. So you could have a container app running using a Python programming language, and one would be using like a JavaScript or whatever, C#, .NET, whatever other programming language or framework that you use. Dapr would still take care of that. And these are some of the building blocks that actually Dapr provides to developers. For example, if you've got a publish and subscribe architecture, it helps you with that. It helps with state management, helps with managing your secrets, and provides you with extra observability. The other technology that I want to talk about, which is part of Azure Container Apps, is Envoy Proxy. So Envoy Proxy is a layer 7 network proxy for cloud-native apps. What that means is that it works on layer 7 in the networking stack, which we would have things like HTTP and gPRC. So the Envoy works in this level. It provides services, a lot of services actually, provides network traffic load balancing, traffic splitting. We talked about traffic splitting earlier. This is a service provided by Envoy Proxy. The idea is that Envoy Proxy is actually intercepting all the traffic. So it helps to provide services like TLS termination. It also provides us with rich observability and metrics, because it is examining every packet. So it adds extra features, and it could also help us with things like authentication, authorization, and encryption. And then finally, we'll talk about KEDA, which is the last open source technology we will be talking about, part of Azure Container Apps today. KEDA is responsible for auto scaling. So it stands for Kubernetes Event-Driven Auto Scaling. It's an open source technology built on top of Kubernetes. It adds extra scalars, or what we call triggers, or what is called scalars within KEDA terminology, beside the CPU utilization and memory. So normally when you exceed a threshold of like how much CPU or memory you are utilizing, that would trigger the scaling of the creation of a second replica or more replicas, depending on how much demand you've got. What KEDA could actually provide us with is, for example, you could have a rule that would be triggered based on the number of concurrent HTTP requests. So if it exceeds, for example, 100 concurrent HTTP requests, that would trigger a rule, and then you will have another replica to deal with the increased demands. There are a lot more. There are a lot more scalars that Replica provide, and it is a very feature-rich. It provides a lot of integration with a lot of multiple cloud providers. One of the some of these triggers are, for example, if you've got messages in the service bus, as soon as you've got messages, that will trigger a scaling rule, or like if you've got events in the Azure Events Hub and more. So that was a brief introduction to Azure Container Apps. If you have any comments or questions, leave them in the comment section below. And as always, stay strong. Kia kaha. See ya.